So this lesson is about the tangent function. So the tangent function is going to be described as, well, we usually describe it as slope, but to get a better idea of how the tangent value changes or the angle changes, we're going to look at the unit circle again. So if you take a look at the unit circle, the tangent line, or the length of the tangent line, is essentially the tan ratio comes from this tangent line, vertical tangent line on the circle, and the tangent ratio is the length that it goes up, or the distance along the y-axis. That distance represents tangent of theta, or tan theta. So let's notice that if we take that ratio compared to the ratio of 1, okay, that ratio of the vertical to horizontal is equivalent to the other way we describe it as the vertical to the horizontal of the position on the circle, okay, because they are similar triangles. So that's how we're going to first of all define our tangent function, that length there. And so as we go around the circle, we want to see how far it's going to reach up along this line. So that's how we're going to frame looking at the tangent graph. So starting in quadrant 1 at 0 degrees or 0 radians, as we increase the angle, we're going to be going up along that axis. So in quadrant 1, we're going to be going up, 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 but at 90 degrees, or when the angle is pi over 2, that line is parallel to the tangent line. And parallel lines never meet. So in this case here, this line will go infinitely long before it touches that line, okay, or it touches this vertical line at essentially infinity. So we have undefined slope at that point. And the same thing, we can think of the slope at this angle, the vertical divided by the horizontal run here is 0. So we're going to have an undefined slope. So that's what it looks like here. As we go increase the angle from 0 to 90 degrees or pi over 2, it's going closer and closer to infinity. Okay, so it never reaches that pi over 2. And the same thing, because it's symmetric, the circle is symmetrical going into quadrant 4, as I rotate this way, okay, backwards to negative pi over 2, I'm reaching further and further and further up that line, and eventually at 90 degrees, those two lines become parallel, and it takes infinitely long before I touch that vertical line. Okay, so there's our tangent ratio. So the way we show that on the tan graph then, the tan function is, it becomes more and more negative all the way to negative infinity. Okay, so the y position here is getting more and more negative below the x-axis. Okay, so there's our tan function, and so the tan function is characterized by this type of symmetry. It has a vertical asymptote at 90 degrees and negative 90 degrees, or pi over 2 and negative pi over 2. And as we go into quadrant 2, there is another tangent line here, essentially. Okay, or we can I can draw it like this. As we go into quadrant 2, and I draw my angle here, my angle is going to reach into the negative sections of that line. So again, it's going to be below the y-axis. Okay, so as I go into quadrant 2, I'm going to start at negative infinity, and I'm going to get closer and closer to 0. Okay, so that's what it looks like. So the tangent graph then starts at negative infinity slope, okay, or negative infinity where it touches that tangent line all the way to 0, and then through quadrant 3, okay, we have these angles here. If I draw a tangent of my angle in standard position, it's going to reach back onto the positive y-axis. So then we're going to go back up to positive infinity. And as we get closer to this point here, we're reaching higher and higher up. Okay, as we get closer to pi, we're going closer to, our slope is getting closer to 0, or is touching the 0 position on the y-axis. Okay, so there's two perspectives there. We can think of it as slope perspective, or we can think of it as perspective, where is it going to touch the tangent line when I extend the standard position, right? Extend that standard position back to the tangent line.